So here we have a triangle ABC and we need to show that the given trigonometric equation is true. Let us begin. First, we will specify the law of cosines because that will be used to prove the following. So let's begin. So let's consider a triangle ABC, an acute angle triangle with vertices A, B and C. Here the sides opposite to angle A, B and C are represented by lowercase letters A, B and C respectively. Then the law of cosine states that the cosine of A, cosine of B and cosine of C can be defined by the sides as given in the following. Now we'll start from the left hand side of a given trigonometric equation. So here we have 2 multiplied to BC cosine A plus EA cosine B plus AB cosine C. We're going to multiply 2 to each of the terms. So we have 2 times BC multiplied to cosine of A. Then the second term we have 2 times CA multiplied to cosine of B. And in the third term we have 2 times AB multiplied to cosine of C, which gives us 2 times BC multiplied to cosine of A. The cosine of A that will be replaced with B squared plus C squared minus A squared divided by 2BC plus 2 times CA multiplied to cosine of B. So that will be C squared plus A squared minus B squared divided by 2CA plus 2 times AB multiplied to cosine of C. So that will be A squared plus B squared minus C squared divided by 2AB. So we can cancel out 2ABC and 2BC from the numerator and the denominator of the first term. Similarly, we can cancel out 2CA as well as 2AB from the third term. Now that leaves us with B squared plus C squared minus A squared in the first term. Then from the second term, we're left with C squared plus A squared minus B squared. And from the third term, we're left with A squared plus B squared minus C squared. So we can cancel out B squared with negative B squared, positive C squared with negative C squared, and negative A squared with positive A squared, which leaves us with A squared plus B squared plus C squared. And that's the expression on the right hand side. Hence,